down this definition of continuity. So write down definition of continuity. Okay, the idea of continuity refers to the following. So if I have a function, draw a picture like this, just some simple graph. Okay, and I should have clarified this. This is the definition of continuity at a point. So it's determining if a function is continuous at a single point. If you want to find out if the function is continuous at all points, you simply apply the definition to all of the points. But the definition is talking about one point. So here's a function. It's just a collection of xy pairs. I just draw something at random. Doesn't really matter what. If I'm trying to identify if this function is continuous at a point, and we'll use kind of the language that the AP test uses on occasion, we'll say this is an x-coordinate A, and we'll say that the y-coordinate is L. Now, the A and the L are random. They could have chose any letter they want. That's what somebody chose years ago, and they just kept using it. So don't affix any sort of special meaning to the A or the L. Questions so far? Anything pops to mind, just ask. This is just a very open discussion. Okay, so we have a function, we call it f of x, we're kind of paying attention to this special point here at a comma L. I'll label that as well. It's the function f of x. Any questions? All right. The definition of continuity. Now, I wrote this as a comma L. We could have also said this is the same thing as saying that the value of the function at A is equal to L. Is anyone uncomfortable with that notation? Are you okay with that? Okay. Now the key thing to recognize is this is telling us about one point. There's an infinite number of points here, so there's an infinite number of points along this graph. But this statement is talking about simply one point. Okay, now we've also talked about limits. So there are a couple of other points here. There's a point here on the right that's infinitesimally close. We would say that would be at about 8 plus. And I don't know exactly what the y-coordinate is, so I'll just put L. I just know it's close to L. And then this also implies that the limit, as x approaches this x-coordinate of A from the right, the limit of that function is also equal to L. See what I'm comfortable with that? Give you a chance to get that written down. I'm watching for your pencils. So the crucial thing is to make sure you understand that this statement, f of A equals L, is talking about the green dot and only the green dot. This statement, the limit, as x approaches A from the right, is talking about this kind of brown maroon dot, nothing else, just that single value, that's it. Don't ever think that because this is equal to L, this has to equal L, it doesn't. With me. The third dot is the one on the left. It's over here. So there's a lot of AP questions you'll encounter where they are asking you to think of those three dots. And remember that the dot on the left is referring to the left-hand limit, the dot on the right is referring to the right-hand limit, and the dot in the middle is the value of the function. So this image needs to be basically clear in your mind so that you can recall it anytime you encounter an AP question that kind of delves into these concepts. Any questions so far? Okay. The definition of continuity says the following. It says that a function is continuous function is continuous at a point, for example, x equal a, if the limit of the function as x approaches a from the left is exactly the same thing as the limit of the function. Let's do it this other way, sorry. It's exactly the same thing as the value of the function, right, at a, and it's exactly the same thing as the limit from the right. So the limit definition matches up perfectly with the 3 dot idea, where this part of the definition is talking about the dot on the left, this is the dot in the middle, this is the dot on the right. Time to pause and catch up in your notes and ask about anything that happens to pop to mind. Please talk. Okay. The idea is that you're going to be tested on whether or not you can recognize for some situation if the function is continuous at a point. So for example, now this example, the function is continuous, so here's what happens. We'll do the ones that aren't in a second. So here's what you have to be able to call from memory. They're asking, is the function continuous at x equal a? So what you have to do is say, okay, wait a minute. To be continuous at x equal a, there must be a value of the function at a. In this example, the value at a is L. So you know that f of a is equal to L. So that's the first thing that is required for the function to be continuous. That's not enough, however. It is also required that the limit from the left, also be equal to L, and the limit from the right also be equal. Because all three, this one, and this one are all equal to L, that matches the definition. They're all equal to the same y value. That confirms, it proves mathematically that this function is continuous at this point. That's what they're referring to when they talk about the definition of continuity. Not sure that helped. No, you got to think of those separately. The thing is, what mathematically proves that something is continuous? What proves it is these 3 values being the same. So they're going to ask the question one of 2 ways. They're either going to say, prove to me that a function is continuous. You've got to go figure out what's the limit from the left, what's the limit from the right, what's the value of the function, and then you tell the grader, hey, all 3 of those are the same value, therefore I know for certain that the function is continuous. That's one approach they'll give you. The other approach is they'll say, if these 3 things are the same, is the function continuous? You say, yes, it is, because all 3 are the same.
Can they give you an equation to plug in? Like
Not necessarily.
Okay.
They may give you an equation, they may give you a graph. I've never actually seen them give you a table, but they could.
Okay.
It's the same thing that I emphasize all year long. They're not testing you on steps, they're testing you on ideas. And this is the idea, and you've got to make enough sense of the idea that you can apply it to some problem you haven't seen before. That's what they're doing. Other questions? Perfect. Okay, let's go to the next page. So this was an example of a function that is continuous. Here's an example of one that isn't. Let me get a new page here. Hold on. So, actually, let's just get you to earn some tickets real quick. So somebody raise your hand and tell me, what is one requirement for a function to be continuous at, let's say this, what do we want is what f of x is continuous at, we'll throw in some numbers this time, x equal 5. So what is one requirement, so this is an if, what's one requirement for the function to be continuous at x equal 5?
So the limit of 5 negative would have to be 5 too.
Nicely done. Close. The limit as x approaches 5 from the left, 2 for Jeff. This doesn't have to equal 5. This doesn't have to equal 5. But close. Like, this is definitely involved in proving. We're trying to show that a function is continuous at x equals 5 if this is, somebody help me, what goes here? Who said 2?
I did.
That'll
We'll
work.
just pick a number, right?
For our discussion, we can just kind of pick it randomly. So if this is 2, Landon, what else must be true if the function is going to be
If
continuous?
it's continuous and if it's approaching it from the right, and it also has to be.
Now you got the right idea. And the way you did that was perfect, Landon, because you were focused on the concept, not some sort of step.
Yeah.
You're thinking, okay, wait a minute, if I have a function, and the function is going to be continuous at x equals 5, then what has to be true about the function? Well, this limit's going to equal some value, just making this up anyway. And then the limit from the right's got to equal the same value. That's perfect, 3 tickets for that. This is not quite enough to guarantee continuity. What else is required for the function to be continuous at x equals 5? Someone else, Ellie. Perfect, 3 tickets for that. The function can't have any jumps, holds, vertical asymptotes. You'll use that all the time if they give you a graphical question, where they show you pictures. In this case, no graph, we're just trying to understand it with equations. So what else is missing, Sarah? The middle dot, perfect. So there you say it's not approaching anymore. Yes, it's when x is exactly 5, the y-coordinate must be exactly 2. And all 3 of these, the limit from the left, limit from the right, value of the function, the 3 dots have to do the same. Perfect. There you go. Question? Anyone, please. Great.
Could the answer ever be like 2 minus or 2 plus? And still be
Yes.
continuous?
Well, the limit will always be 2.
Okay.
What you're thinking is something like this, that if you had a function and we were at x equal 5, like so, is it possible for the function to do something like, say, that, where the value of the function at x equal 5 is exactly 2, but the point on the right is maybe at a value of, say, 2 plus, and, oops, I did that wrong, sorry. Value of, say, 5 plus, and maybe 2 plus. Is that what you're thinking?
Yeah.
Yeah, that's totally valid. This still makes the limit equal to 2.
Okay.
And so these 3 are still, these 3 here are still perfectly equal to each other. No, it's perfect. Please talk.
Okay, so, trying to figure out like this. So, we did a random number for x, which was 2. But for an actual equation, like the way they would say it, how would it look?
Oh, very good. Based on the past, Todd, the way they'll kind of present the question is they will pick some value as well. So they'll ask you to investigate whether the function is continuous at 5 or not. And then you'll be the one who figures out that at x equal 5, the limit turns out to be 2, because they'll either give you a graph or they'll give you some equation to allow you to figure that out. Does that help? Yeah. Okay, cool. 2 tickets. Anyone else? All right, next thing. Let's do this discussion. Let's say insert. There we go. Okay, the way Sarah's remembering it to me is the best way. Okay, she remembers 3 dots. You gotta have 3 dots for the function to be continuous at the middle dot. You have to have the middle dot itself, you have to have the dots on either side. Okay? So, going back to Ellie's comment, the function is not continuous if it has a hold, jump, or asymptote. So somebody raise your hand and tell the class the following. If you're talking about a hold, what's the problem? You've got the 3 dot idea again, limit on the left, limit on the right, value of the function. What's the problem with a hold? Like what's missing? The limit on the right, the point, or the limit on the left? Like why is a hold not considered a continuous function? Sort of.
Isn't it because the point is undefined?
Nicely done. So if you have a hold, read for sort. The graph has a feature where the function is defined for these different xy coordinates, and then suddenly it's say x equals 3, there is no value of the function. So f of 3 being undefined, there's no way to have 3 dots that have the same y coordinate if the dot in the middle simply doesn't have a y coordinate. It's perfect. Any follow-up questions to that? Huh? So the function as a whole at x equal 3, it could be anywhere, so, but just x equal 3 is an example. Then the function's y coordinate at x equal 3 is unknown. We don't know what it is. So the definition of continuity requires that for the function to be continuous, you'd have to have the limit from the left, which in this example, there would be some limit from the left. Maybe it's equal to, I don't know, we'll say that's pretty close to 2. And the limit from the right is also 2. However, the value of the function at 3, we don't know what it is. So because these 3 things are not all the same, the function is not considered to be continuous at 3. Is that kind of what you did? All right. What else? Okay.
Maybe I should just be, no, it is not confused.
Well, again, I'm not giving you an AP problem here. I'm just presenting an AP idea. Yeah, thank you. Like, I don't know how they'll ask the question. They change them up every single year. But the idea is that you have to understand that the reason this type of function would not be continuous is because it's not defined at 3. That's what you're supposed to catch on to. Perfect. What else? Cool. Okay, that's the definition of continuity. The other clue you need for tonight's homework, and then we'll let you work on it for the last half hour here, is this. Okay, horizontal asymptotes. You've studied horizontal asymptotes before. I want to make sure you don't make a mistake on your recollection. A horizontal asymptote. A lot of people have the misperception that if a function has a horizontal asymptote, the function will never touch and the function will never cross the horizontal asymptote. Say this is at y equal 4. I've had several students tell me that it is not possible for the function to look like this if the function has a horizontal asymptote. But at y equal 4. But that is a false recollection. This is totally valid. This function has a horizontal asymptote at y equal 4. Whoa. This function has a horizontal asymptote at y equal 4 because eventually the y value is getting close to 4. But it does not matter what the y value does back here.
What?
Say it again, Chuck.
I've already achieved this. Was weird coming up.
It's what it is that you're just not familiar with it.
Yeah.
But you just need to get familiar with it. It's because the homework problems you did in previous classes never gave you some sort of function that did this. They gave you functions that did, this sort of behavior.
Yeah.
Is that fair?
That's more like it.
Yeah, and so you get the idea that if there's a horizontal asymptote, the graph will never cross the asymptote and it will never touch the asymptote. You've got to delete that from memory. Okay? Delete.
Cancel.
Perfect.
Cancel it out.
It's just not right. If there's a horizontal asymptote, the function can touch the asymptote, the function can cross the asymptote. It's just that eventually it will only get close.
Wait, is that the same with the vertical asymptote too?
No.
No. Wow.
Vertical asymptote behaves, that's why you get them mixed up, is because you start to think that vertical and horizontal behave exactly the same. They don't. They'll test you on it. They seem to have a question every single year. And as long as you chat, it's actually pretty straightforward. As long as you keep those ideas separate, vertical separate from horizontal, you won't be fooled by their question. That's all. So you'll be better than half the country. Please. Yes. So the idea of a horizontal asymptote totally separate from the idea of continuity, Sarah. Good question. Please.
So what if, I don't know if this is possible, but it was like, if it came back on itself?
Oh, if the function curls back on itself, it's no longer a function.
Okay.
So they won't ask. What is the comment about horizontal asymptotes? Then you're going to work on the homework for 30 minutes. Listen, when they say the word horizontal asymptote, you should immediately think to yourself, that is exactly the same thing as finding the limit of the function as x approaches infinity. Like, you need to have that memorized. So for example, if I say f of x has a horizontal asymptote at y equal 3, you know that the limit as x, so you'd say, so the limit as x approaches infinity of f of x is also equal to 3. Declaring a horizontal asymptote and the value of the limit, those are the same thing. Good question. You've got to make this link. They say horizontal asymptote, you've got to think limit as x approaches infinity. If they say limit as x approaches infinity, you've got to think horizontal asymptote. Please.
If like the function or the, I guess the equation was like infinite both ways, could it approach, could like the negative infinity would still have to only approach y equals 4, or could it be that? Does that make sense?
You could actually have two different ones. You could have, as x approaching negative infinity, the limit might be a different horizontal asymptote, like 5 or something. The good news is that on the AP test, for whatever reason, they kind of avoided this. They haven't really ever asked a question about horizontal asymptote in the other direction. But the idea is basically the same, chat. It's very good. What else? Please. Elsie.
So how would you figure out that it, because like on the graph you can't see that it is going to have horizontal asymptote, so how would you see that?
Got it. They would have to give you enough information either in words or in the picture to show that even though the graph is kind of oscillating up and down, that eventually it is getting close. Yeah, they can't just give you a picture that oscillates and expect you to assume that it levels out. So they'll give you enough of that. Question else? What else? Please. So giving you a little head start there. We'll get started in a minute, then we'll have you work on a little bit yourself. Look up at 26. And this is the challenge of this homework. Everyone look at me. The challenge of this homework really is, I can show you every single problem, we can talk about it, you can ask questions, but somehow you've got to kind of make that jump to fighting through it. Like you just have to. There's just no other way around it. So that's why this last 25 minutes now will be useful, because you can kind of skip the ones that look like they're things you could do on your own, kind of focus on the ones you might need a little clue here or there. But here's how I would solve this problem. 26 says, just get a marker. 26 says the limit as x approaches a of some function is equal to L. Pictures really help. So I picture a function. They're talking about an x coordinate of a. Draw A. And they tell me that the limit as x approaches a is L. So L is a y coordinate. And then let me go back to Sarah Parker's earlier comment. You're thinking of 3 dots. Somebody answer this question. This information here regarding the limit, which of the 3 dots is this question talking about? Is it talking about the middle, the left, the right, all 3, 2 out of 3? Raise your hand, please. What's it talking about? All the things they know. Okay, everybody's willing to try. which of the three dots is it referring to when it says the limit as x approaches a is L? This is what they're testing you on, is your conceptual understanding of this. Let's try Jackson.
Middle one.
So Jackson both said they're talking about the middle dot. How many agree with Jackson? Show me your hands. 2 points for all of you, but they fooled everybody.
Boo.
Oakley says all three. They fooled Oakley as well. No offense. 2 tickets. Hey, Chance.
They were outside ones.
Yes, limit only refers to the one on the left and the right. So the limit is not talking about the middle dot at all. The limit is only talking about the value of the function on the right of x equal a and on the left of x equal a.
Yeah,
That's what they're
Chance.
testing you on. So that I know that there is a dot on the left, there's a dot on the right, and I know that those two y coordinates are very, very close to a y coordinate of L, because that's what the limit statement says. Yeah, please, sorry.
Well, isn't D technically asking about the middle one? Because it's saying, yeah, because isn't, when F of A is L, isn't that the middle point?
Yeah, D is definitely, the statement in D is definitely talking about the middle point. Yeah, what I was asking, apologize if I misled you, is what is the clue talking about? So the clue alone, it's very good, Soren. The clue alone is only talking about the left dot and the right dot. The clue gives you the fact that the left dot and the right dot are very close to a y coordinate of L. But the clue doesn't talk about anything else. The middle dot is not even mentioned in the clue. Questions about that? The focus is very good right now. Okay, so now you start answering the questions. Somebody answer this one for me. Here's the crucial part. You cannot in this homework do the following. You can't simply look at a problem, think, I don't really get it, look at the answer, turn back, look at the problem, say, oh yeah, that makes sense. Look at me. I promise that that's all you do, you'll get nothing from this homework. And you'll be in trouble for the test in a couple of weeks. Like, you literally have to say, is every little part of this making sense to me? You have to fight your way through it. So, the first one, somebody explain, is this a true statement, a false statement? Is A something that could be true? Is it something that must be true? What do you know about statement A based on the clue? Todd?
That it's the middle dot, right?
So statement A is absolutely talking about the middle dot. Statement A is saying, does f of A exist? Is there a y coordinate when the x coordinate is A? And what you've got to do, Todd, is say, if I know this clue, is this a true statement? Keep talking.
Yeah, this is a true statement because we need a middle dot in order to have a left and a right dot. Right?
3 tickets for a good shot, but they fooled you successfully. Because you can have a dot on the left and a dot on the right, and if there's nothing in the middle, what do we call that? Well, we call that a hole. You can even have a jump where there could be a dot, say, down here. So there's actually 3 dots. There's a dot on the left, there's a dot on the right, and there's a dot in the middle, but they're not all together. Them telling you that the function has a limit tells you 0 information about the middle dot. You just don't know anything. Follow-up questions. Your thinking was very good. That's what they're forcing you to do, is think through the problem. Can't memorize steps on this at all. Somebody comment on B, please. What do we know about statement B? Let's go ahead to Sarah.
We know that if f of A equals L, then it would be true that.
Oh, that's well done, Sarah. And the way you explained it was perfect. Yeah. F of A, sitting against her, what equal to what, Sarah?
Equals L.
F of A were equal to L, then f of x would be continuous at x equal A. It's perfect. But since we don't know anything about f of A, is this statement A, Sarah, is this statement A must be true, must be false, could be true, could be false?
Could be true.
Could be true. Statement B could be true if we had more information, we just don't know. We don't know anything about the middle documents. Perfect. 4 tickets for that. Follow-up questions on B. Okay, I'm kind of giving you a big head start on this one. I'm going to let you work on it. Spend the last 20 minutes, work on homework problems, ask me questions. This is the kind of thing you're going to have to be thinking through on each homework. So, yo. Just don't fool yourself by simply talking yourself into an answer. Don't ever do that.
So I think that's on our
I like your pajamas.
Thank you.